Today we are having Dr. N.B. Kalani with us for sharing the session. So I would like to give a brief introduction about Dr. N.B. Kalani. Dr. N.B. Kalani is presently working as a director at RK University. He has passed his graduation and post-graduation with distinction from Shantilal Shah Engineering College and MS University respectively, and he has done his PhD in Electronics and Communication. He has 19 plus years of academic experience at various institutes like VVP Engineering College and RK University. He has 4 years of large-scale industry experience. Dr. Kalani has been invited as subject expert of selection of faculties at various institutes. He is a member of the NBA advisory body at different institutes. In addition to this, he has delivered expert talks on various technical topics, course designs, innovative assessment techniques, goal settings, mentoring, and many more. He has been selected for AICT UK India Research in Education program for the year 2019. He has received Best Paper Awards in many national and international conferences. He has been honored as a fellow for Institute of Electronics and Telecommunication Engineering, IETE India, in October 2016. Dr. N.B. Kalani will be delivering a session on acquiring data from sensors, uploading sensor data on cloud and MQTT protocol. So I request Dr. Kalani to take over the session.
Good afternoon, Kalani sir. I think you are in mute or no? Your voice is not there. You are not audible to us.
Audible now?
Yes, sir. Now it is audible. Yes. Are you able to share your screen? Prapti madam, you have to make Kalani sir as a presenter so that
yes,
you can.
Yes, sir. We have already checked. He is able to present.
All right.
Yes.
Hello, sir.
Yeah,
is it visible? No? Screen is shared.
Yes, sir. It is clearly visible.
Oh, okay. Thank you for the info.
In between, there was no voice.
Okay. So yeah, no issue. So as you are aware, my topic is reading sensors and sending the sensor data to cloud and MQTT. So basically, sensor is a device which provides a usable output in response to a specified measurement as per the ANSI definition. And Merriam-Webster says that it's a device that responds to physical stimulus such as heat, light, sound, pressure, magnetism, or a particular motion and transmit a resulting impulse as for measurement of or operating a control actually. And the simplest one would be like they are the input devices which convert one type of energy or quantity into an electrical signal. So we will not be discussing much about the types of sensors because you people must be knowing a lot about it. But there could be many challenges when we try to interface sensors or we try to read sensors. One is the type of the sensor output. As we know, the sensors can be of analog nature or digital. Then if it is analog, then the output could be in the form of voltage or current. If it is digital, then the output can be, we can take it parallelly or serially. If it is serially, then also it can be synchronous or asynchronous. If the output is asynchronous, then in that case, RS232 or one wire, or if it is synchronous, then in that case, whether it is SPI or some other protocol. So all those things we have to take into consideration whenever we want to read a sensor data so that we can do the proper connections. Another issue is the signal level, output signal level. Sometimes the value is so low, then the signal conditioning is required. The distance between the sensor and the measuring device, the environment in which we want to read the data, the power utilization, as the ultimate goal is to keep it as minimum as possible, and the presence of noise. So all these things we have to take care of whenever we are trying to interface with sensors. Here I'll be giving you a demonstration actually of interfacing a temperature sensor, temperature and humidity sensor, DHT22, and I'll be using the same example to cloud. Okay, so we will let me first introduce you with the board which I'm going to use. Okay, the board which I'm using right now is Node MCU. It's a microcontroller, 32-bit RISC CPU. The operating voltage is 3.3 volt and it has 16 digital I/O, 1 analog input pin, UART, SPI, and I2C1. It has a flash memory of 4 MB. It's a very tiny board costing around 250 to 300 rupees in the market, and has the Wi-Fi capability also, BGN protocol it supports. I found a very good diagram on the instructailable.com. So here the good thing is that they have mentioned all the pins, which type of pin are there, then the color they have mentioned. So it becomes very easy when we are trying to connect the board with the different devices. Yeah. The sensor which I'm going to use is DHT22. As you can see here, it has 3 output. The first pin is the VCC. It needs a supply voltage between 3.5 to 5.5 volt. The last one is the ground, and in between is the data out. It's one wire. It works on. It's a digital output sensor actually, and it works on the one wire protocol. The temperature range for DH222 is -40 degrees centigrade to 80 degrees centigrade, and the humidity range is 0 to 100%. There is a low cost option also, DHT11, which has a temperature range from 0 to 50 degrees centigrade and sensitivity, this humidity up to 80 degree. Okay, so you can use either of this. The cost of DHT11 is somewhere around 100 to 150 rupees, whereas the DHT22 costs somewhere around 250 rupees. And this is the simple connection diagram, which you can see here. Very simple. One of the pin, GPIO pin, we have to use to the digital IO pin. We have to use to read the data from the DHT22, and VDD and ground we have to give. In some of the diagram, we do see that pull-up register, but it may not be required here where the this sensor it is having inbuilt. Okay. Here is the connection diagram which I have done right now. So I've taken a picture of it and put it here so that it's very simple 3-wire connection, and this black wire you can see here is connected to the laptop. So let us see the program. First, we'll go to that program first, and I'll show you the first program of reading this particular sensor data using Arduino IDE actually. Arduino do support this, and for that what we have to do is whenever we are interfacing in this preferences, we have to put Node MCU board link actually, that board manager link that I'm here you can see that HTTP Arduino ESP8266, because Node MCU is actually based on ESP8266. So that link we have to put it, and then we have to add the board. So here from that you can see the board manager. When you go to the tools menu of Arduino IDE, and in that you can see the board manager, and once it is added, you'll be having the options. I'm using Node MCU 1.0 ESP12E module, so I've clicked it. The program you can see here, I think already in the previous session, some of this was already discussed. I'm using DHT, I'm using pin number 4, GPIO pin number 4 to get the data. So that I've configured. The library has to be added whenever you are using this digital sensors. So for that, in the tools, you can see manage library option. And when you go into that manage library, you'll be able to see all the libraries available. And then here you can type the library, and then if, for example, here ESP8266, okay, then it will give us all the options which are there, and then you can install the one whichever you want. I've already installed it, so that's already there. And if you talk about the program is calling this DHT library, and we are using two variables here, one for the humidity, one for the temperature, and both are defined as a floating type here. And the serial communication right now is at 9600 baud. So you can see it here, and DHT.begin, it will initialize it, and then this program starts here. From that, initially for that initialization period, we have put a delay of 200, and then H, this particular instruction, what it does is it reads the, using that DHT library, it is reading the humidity data and the temperature data. The humidity data is assigned to the variable H, whereas the temperature data is assigned to the variable T. Now DHT22, for each reading, it gives 5 bytes of data. The first 2 bytes corresponds to humidity, and the next 2 bytes correspond to temperature, and the last byte is CRC. Okay, so that is here, and this I in this particular program I put it at comment, but whenever sometime it may happen that the connections, physical connections are not proper, or maybe the sensor is not working, so it is not giving any data. So at that time we can have something like this, where whenever there is a none value getting written, then it can be printed on that. And then serial print humidity, and then the humidity data, and then the percentage, and then the reading of temperature, and then the printing of Celsius. Okay, and this is being done with a delay of 10 seconds. So let us see the output in the serial monitor first. Is this visible, sir? Serial monitor?
Sir, it is visible, but actually the print size is very small.
Very small.
And it may increase,
okay.
So that participants can view it clearly.
Just a minute, ma'am.
Actually, participants are sharing that.
Yeah, I'm trying. Okay, is it visible now? Is it?
Yes, sir. It is visible.
Okay. Do you want me to increase it further?
Yes, sir. It would be more. It would be better if it is increased. Yes, sir. It is visible.
Okay. So this particular program, as you can see, is reading this humidity and temperature bytes. They are getting read every 10 seconds. The humidity data is assigned to the variable H, which is of float type, and temperature data is assigned to variable T. And here we are doing that printing, and you can see the COM port serial monitor where the data is getting read and getting printed here. Yeah, humidity 40 right now in this my cabin. Humidity is 46.70% and temperature is 27.5 degrees Celsius. Now this is what we can do, means we are reading, but the next question is that how will we store it? Okay, we are just saying it here. So one easy thing, everybody is having Microsoft Office. Okay, so one easy thing to do is, would it be possible to store it in Excel, the same data? Yeah, so it is possible. So let me show you how to do it using Excel. Okay, so Office 365 supports this, and when you open it, you'll be getting something, a display something like this, and you have to go to option, and in option you can see a menu here: general, formulas, data, proofing, save, language, everything. And then the second last one is add-ins. Okay, in add-ins, when you go to that, in the bottom you'll find manage. So in that manage, when you click on it, there are Excel add-ins, there are COM add-ins and anything. So just click on COM add-ins and you'll be seeing these add-ins. I've already added. What I wanted to say is that there is one add-in called data streamer in Microsoft Excel, which can be of help. So I've clicked it and done. Okay. So once it is done, it gets added here, and that you can see here after help, you'll be seeing data streamer. Okay, added there. So now let me have a new blank book. Okay, before that I must close the this monitor, because two different devices or APIs cannot access at same time. So data streamer, you can see a normal Excel file, but here there is one more in that menu, there is data streamer. So once you click on it, you'll find a new row here where you can see connect device. Okay, as the first button. When you click on it, generally whenever we use this board like this, we have to also download the driver. So that driver is that Silicon Labs. So it has already identified it, that, and it is connected with COM port 4. So when we click on it, you can see a different view popping up in front of you. Right now, the baud rate is at 960 and the data getting read at 150 interval, but we can change this by going to the settings menu. And in setting, I'm changing this to just a minute. 100 millisecond, and I'm interested in just 2 channels right now, because humidity and temperature. So I'm putting it as 2, and we have both the options. As far as data presentation is concerned, we can put the newest last or we can put the newest first. So I'm doing that, and once we do it, you can see here the change. Now it has changed to it has changed to 2 channels only. Okay, so now our the sensor data is there, it is connected, we have defined 2 channels, and now what we have to do is we have to click on start data. So what it will do, it will start streaming the live data, whatever is coming. Before a few minutes we were seeing it in the serial monitor, but now it will go to this file. Okay, so once we start this, and within maybe a few seconds it will come here. Yeah, so here you can see timestamp. Yeah, so the data is getting read, and the data is coming up one by one, and you can see here the last reading is 47% humidity and 27.5 degrees Celsius temperature. So it will keep on reading, and based on, yeah, any question, ma'am? Okay, so it's coming here continuously, and we can record the data also here. Yeah, so all this data gets recorded into a file, CSV file. It will prepare it. Sometimes we are using a different baud rate. So if you want to change the baud rate, you have to click on the advanced, and in that you need to go to settings. If your device is at some other port, you can change the port, and you can change the baud rate also from here. Yeah, so this way you can read the sensor data into Excel. I'm now stopping the recording. So now it is asking me that where do I want to save the file. So you can see that it is now stored in the .csv. Right now I have not stopped reading the data. So reading is simultaneously going on. Okay, I have stopped recording the data, but reading is going on. So when you want to stop it, stop, and then once it is done, what you need to do is disconnect the device. Otherwise, that particular COM port gets associated with this particular file. Okay, so this way you can read Excel data into this. Read DHT sensor data into Excel file. Now let us go to the another demo, and that demo is taking this data to the cloud. So before that, we will be going to that presentation again, and meanwhile my colleague Professor Vijay Dubey will be helping me to configure the board again, so that we can give you another demonstration of that how the data can be read to cloud. Okay, so let us discuss few things. These are some of the prominent IoT platforms in front of you: ThingSpeak, Carriot, Ka, ThingsBoard, Mainflux, Thinger, DeviceHive, and there is many are there actually. AWS, this, that, so many. The problem is that majority of them are giving you, only few are giving free access, and that free access is also for limited period. Okay, and there is one more, that is Circus of Things. Okay, and that is also free, so you can explore all these cloud platforms based on your interest. I had also seen, and but maybe because of lack of time I'm not able to share it today, but in Google Sheet also we can read the sensor data. There is a JavaScript available for that. You can find it in GitHub, and you can integrate that code into your Google Sheet and connect the COM port and read the data from that port to directly to the Google Sheet. Okay, so that is also possible, and that link of that sheet can be shared with anybody. So it becomes something like that. Your data, which is at particular location, means in the cloud, can be accessible by many. Okay, so ThingSpeak, let us see a few things about ThingSpeak. It's a widely used open IoT platform for collection, storage, and visualization of real-time sensor data fetched from boards like Arduino, Raspberry Pi, BeagleBone, Black, and other boards. It gives live streaming of data on the cloud by some preserved channels. Actually, I'll show you that also in a few minutes. And what you need to do is just create a free account, because they give you. You can connect a free account in ThingSpeak, and after successfully signing up on this ThingSpeak, a channel can be created. I'll show you, and then you can create your write keys and APIs and all those things. So that you can then those keys you need to add to your program actually, so that this the API can be interfaced, and this data can then go to the cloud. Now the key features of ThingSpeak are the configuration of device for sending data to a cloud-based environment. It allows aggregation of sensor data from different devices and motherboards connected with the sensors. It also gives you visualization facility. Okay, I'll show you some of the widgets, okay, of real-time sensor data, including historical records. So that also I'll show you. Some other previously fetched data is also there, and there is a possibility of pre-processing and evaluation of sensor data for predictive analysis and knowledge discovery. Okay, and the good thing is that it's MATLAB product, so most of the academicians are well with MATLAB, so you can use those files for a lot of other processing also later on. So let me now take you to that program, the program of interfacing this same DHT sensor data. I'm taking to the ThinkSpeak cloud. I hope the font is visible, ma'am.
Sorry,
Yeah, I'm still having. Yeah, please. Yeah, is it better now? Okay. So now we are using ThinkSpeak. So the first thing is that the library of ThinkSpeak you need to download. Again, the procedure is same. Go to the library manager and click it and get it done. We are using, I forgot to mention earlier, but this Node MCU is actually based on ESP8266. So that library is also needed. So that also we need to include. DHT.h is also required because that is the sensor library. So these libraries, they are already included. Now here you can see some variation here. That variation is many a time we don't want, when we are discussing with other people, we don't want to disclose the SSID and the password of our wireless network. So in this Arduino examples itself, you'll find a write multiple bit program. And I have modified this program in such a way that I can fetch the data from this sensor and take it here directly. And in that you'll see the secret.h. So that is here, and that secret.h takes care of hiding your SSID, your password, your channel ID, and your API keys. Okay, so it's a good thing to do. So I keep it as it is, and then from there it is getting assigned here. Okay, and again the setup is same. DHT pin 4, this GPIO pin number 4 is used to connect this data pin of DH222 sent. Those the same things are here. Here serial begin, I use a different baud rate because now it can support this. So 1,15,200 baud rate. This 55 scanning another thing, then begin client and DHT begins. What it will do? It will initialize all those things, and in the loop you can see that first it will try to connect to the network. Okay, so that part is here. So it is the SSID is already known to it, password is also there. So if it is not connected, then it will do that, try it, and meanwhile at that time it will be printing that. So let me show you right now. The code is running. Let me change the baud rate here. And I've already downloaded the program because sometimes it creates issues. So you can see that within a few minutes that data should come here. Is it connected or not? I'll have to check. Yeah. Okay, I will reset the Node MCU board. Okay, let me download it again, and so that it will do the connection again. So this part will take care of it. And okay, there is some issue now with this code. Okay, the same code is giving issue now, so let me stop the screen sharing for a couple of minutes and I'll be back with it.
I think, sir, header file should be in the same directory. Thingspeak.h header file.
Sir, this code was already tested.
Oh, okay.
Yeah, and even 30 minutes before it was working. So that's why it's somewhat surprising that why it happened like this. Just a minute, sir. Give me a few minutes, please. Sorry for the inconvenience. Just please stay tuned for a couple of minutes. I'm trying to reload the program and see if the problem gets solved, but somehow there is still issue. So what I'll do, I'll take you to this ThinkSpeak cloud, and here in this cloud, you can create a new channel. Just a minute. Did I share the screen or not? Yeah. Okay. Sorry for that technical inconvenience. There is still some issue with the code. It's the downloading itself is creating a problem, so I'll have to check it. But meanwhile, you can check it if you wish. Yeah. So my colleague will check the again, and meanwhile I'll explain you the ThinkSpeak. So once you have logged into it, you'll get something like this, where you can have a new channel as per your whatever name you wish to give. For example, I want to give it to something like this, FDP, and this for demonstration purpose, and whatever number of fields you want to keep, you can keep it here. For example, for our particular program, we are giving it to humidity and temperature, so we can set these two fields at this, and it gives us a facility to have 8 fields here, and the save channel. So what will happen now, a new channel with that name is now created. You can see the channel ID. So for the program, you'll need this channel ID. You'll also need this API key. When you go to that API key, you can see that it has generated API key for that, and you can create a new API key also if you wish. Okay, so it will generate a new, but this API key and channel ID would be required when you are writing the program. So note it down, and you can make it public view or private view. So let me show you the with the same program what data I was getting. So I had created a channel called node MCU, and this node MCU channel, you can see that I had collected a lot of data, and this particular field 1 is for humidity. The field 2 chart represents the temperature. We can change the type of this particular chart as a line, bar, columns, spline or step. So that is why here I put it as line, and here temperature I put it as data. But here you can see that at 11:26 the data was 27.7 degree today. Okay, and the temperature at that time was the humidity was 49% here. So, and here you can see the previous data. So every 10 seconds we were getting the data. So all these data they are here, they are plotted here. We can export this whatever data captured by this ThingSpeak as JSON file or XML or CSV, so that you can see it here by just what we need to do. For example, I want to export this humidity data as CSV file. Just click on it, it will download it. Okay, so it is so easy to work with it. We can add widgets also. So here already these three are there: lamp, indicator, gauge, and numeric display. So I've added 2 here right now. So whatever is the last value, red value, the gadget is showing that here. Okay, so that you can see this is humidity 49% and this temperature 27.7 degree. Okay, so that MATLAB analysis and MATLAB visualization is also possible, so you can do it. Yeah, so if I'll be showing you that part again, but let me go back to the program. There was some issue, but never mind. Let me show you the logic, what was done here. So this program, as I've used 2 fields, this H and T, the same variables are taken here with humidity and temperature. And I was printing if it gets failed to read the sensor, then the message was getting printed that it failed to read. But if there is nothing like that, then what we were doing, we were assigning this to this field 1, the data of humidity, and to field 2, sorry, the data of temperature. And then this was done with this part was done with reference to that serial monitor only, that if we are checking it in the serial monitor first, then whether the right data is getting read or not. And then this ThingSpeak write field, my channel number, my write key, API keys, they were getting fetched from there, and it was getting sent to this ThingSpeak cloud actually. Okay. So let me go back to this presentation part. Now we'll go to the MQTT part. MQTT is actually a public subscriber architecture based messaging transport protocol. It is very lightweight, simple, and designed so as to be easy to implement. And it is used in constraint scenario where power and processing capacity is a challenge. If you look at the definition, this MQTT is a this 3.1.1 specification says it's a client server publish subscribe messaging transport protocol. Lightweight, open, simple design to be easy to use and ideal for use in many situations, including M2M and IoT context, where small code footprint is required and or network bandwidth is at a premium. Okay, so if you look at this timeline, it was invented by Andy Clark and one more person at IBM in 1999 actually. And they were looking for a protocol which is very low power as well as bandwidth efficient for connecting the pipeline network actually. And this same protocol was later on in 2010 was it was made open, royalty free by IBM, and then it was the MQTT 3.1. In 2014, this MQTT 3.1.1 was published as OASIS standard. OASIS is Organization of Advancement of Standards Information. structural information standards. And in 2016, it became an ISO standard, and in 2018, the first this MQTT 5 initial was released initially, and this final protocol 2009 was released in 2019 as MQTT 5 was its standard. Some of the basic requirements for any IoT protocol are generation of information from one source that can be transported to many actually. Then whatever data is getting generated should be collected. There is huge volume of data, but that data is in small packets. Many a time the network is unreliable actually in IoT environment. So it should be possible to send data in that kind of situation also. Power consumption has to be the minimum, one of the prime requirement. It is also expecting real-time delivery because many decisions, especially in M2M combinations, happening in real time. The connections are fragile, they may break, they may reconnect again, so it has to take care of that also. The concern of privacy and security is everywhere, so for the IoT protocol also, and it has to be scalable because in future there could be more and more devices getting connected. So MQTT is developed keeping in view of all these above aspects. And if we compare MQTT with very popular protocol HTTP, then you can see the comparison here. HTTP is request response type. MQTT is data centric, whereas HTTP is document centric. If we compare the speed, in one of the article I read that they had done it for 3G testing, and it was mentioned that MQTT is 93 times faster than HTTP based on whatever observations they had. Quality of service, there are 3 levels in MQTT. Then the frame size is very small. Obviously the header size is also small. Complexity is very simple actually. Bandwidth requirement is also very low in case of MQTT. Latency is also low. Throughput is high. And it supports raw binary data actually. It is actually data agnostic, and we can send a variety of data using MQTT, and the power requirement is also very low. So before we go into MQTT, let us first understand what is pub/sub architecture actually. So the publish subscribe architecture is also known as pub/sub pattern. It is an alternative to traditional client server architecture. In that client server model, a client communicates directly with an endpoint. In the pub/sub model, it decouples the client that sends a message. This client is known as publisher from the client or clients that receive the messages, and the clients they receive the message, they are known as subscribers. And the publishers and subscribers never contact each other directly, and even they are not aware of that the other exists. Okay, and the connection between them is handled by a broker. Actually it's a server but called broker here, and the broker filters all the incoming messages and distributes them correctly to the subscribers. So let me show you a simple analogy for that. Okay, I'm not able to display you the whiteboard, so okay, but let me see. Okay, there is a problem displaying the content, so I'm sorry, I'll not be able to do that. I'll have to go back to this presentation only, but I'll try to explain it verbally. Everybody has most of the family we subscribe to newspapers actually, am I right? And we do get newspapers from for example, there is Times of India, there is Indian Express. If we look at the Gujarat, we have Gujarat Samachar, we have Divya Bhaskar, we have Sandesh, we have Akila, we have San Samachar, and so many others which are published in local language. Okay, so we don't go to the press directly to get those newspapers. What is happening is that we are subscribing as a user. We are subscribing to the vendor, newspaper vendor. That, for example, I might be interested in reading Times of India, so I might subscribe for that. Someone else is interested to read Divya Bhaskar, so that person might have subscribed for Divya Bhaskar or something like that. And the news vendor is getting the newspapers from all this press. Okay, they are getting hundreds of copies, or maybe from the Times of India is coming to them, the Sandesh is coming, Divya Bhaskar, Gujarat, Indian Express, Akila, Sans, all those, they are coming to them. Now what this newspaper vendor is doing, based on who has subscribed to what, every day they are taking care to ensure that at their doorstep they get the newspaper they have subscribed to. So here the role of broker is actually like the role of newspaper vendor actually. Okay, so based on the subscription, it will give you the required message. Okay, and here it is called topic actually, that we are subscribing to a particular topic, and the broker will take care of that, and whosoever has published that topic, the broker will take care of sending it to those who have subscribed for it. So here you can see a simple diagram. Here you can see there is one MQTT client actually, which is maybe reading temperature, and it is publishing that. Okay, so that topic is temperature. It is publishing this. This particular data, it goes to the broker. Okay, there are, in this figure you can see there are two clients. One client is maybe a car, want to maybe interested to know what is the temperature of maybe XYZ location or whatever, and there is some industrial device which is interested to know about what is the temperature, and based on that maybe it will turn on the fan to keep the particular location cool or something. So they have subscribed to temperature. Okay, so whenever this whatever data this particular client is publishing, it is going here, and based on who has subscribed to that particular topic, the MQTT broker is taking care of sending that message or sharing that data with the clients. Okay, known as subscriber in this case. Okay, so if you look at the characteristics of this publish subscriber architecture, the first characteristic is decoupling. It is providing three types of decoupling. One is space decoupling, where the publisher and subscriber even do not know each other, and there is no exchange of IP address or port or anything. Second is time decoupling, where publisher and subscriber do not need to run at the same time. Okay, and third is synchronization, that operations on both components do not need to be interrupted during the publishing or receiving. So these three kind of decoupling is possible because of this PubSub. It also provides better scalability than a traditional client-server approach, and the operation on the broker can be highly parallelized, and message can be processed in an event-driven way. Okay. Third is message filtering. Publisher subscriber architecture, it gives us the option of subject-based filtering, content-based filtering, as well as type-based filtering. If you look at the subject-based filtering, then here the subjects are also known as topic, which is part of each message. The receiving client subscribes to the broker for the topic of interest, and from that point on, the broker ensures that the receiving client, that is the subscriber, gets all the message published to the subscribed topic. In general, the topics are string with hierarchical structures that allow filtering based on a limited number of expressions. Second is content-based filtering. The broker filters the messages based on a specific content filter language. The receiving client subscribe to the filter queries of message for which they are interested. One problem with this method is that the content of the message must be known beforehand and cannot be encrypted or easily changed. Third one is type-based filtering, where an object-oriented language are used. Filtering based on type or class of a message is a common practice. For example, subscriber can listen to all messages which are of type exception or any other subtype. Okay, so these three type of filterings are possible. So MQTT is a PubSub protocol. Many a time we read MQTT as an acronym of message queuing telemetry transport, but it's actually MQ telemetry transport, where MQ stands for a particular series. Maybe when they developed this particular protocol at IBM, this series was going on. So it has nothing to do with message queuing. No doubt message queuing is possible for a certain class of service here, but it is no longer an acronym now. It's a protocol, MQTT. It decouples the subscriber and publishers especially, and to publish and receive the messages, they only need to know the host name and IP and port of the broker. That's all, nothing else as far as the client side is concerned. It decouples by time also, and mostly MQTT delivers the messages in real time, but if desired, it is possible to store the messages also, okay, for clients that are not online. But there are certain conditions that quality of service should be greater than 0 and persistence session should be there. So we'll talk about it in later on. So we'll make it will make it clear further. So MQTT works asynchronously. It is easy to use on the client side, and it is very lightweight, as we discuss. All those things we already seen. 3 kind of quality of service levels it supports. Better scalability, and it is based on TCP/IP. So it works on the top of that. So it is expected that both the client and broker, they have to have a TCP/IP stack. Okay. Now, what is MQTT client? Client, as we have seen earlier, they can be publisher as well as subscribers, and it can be any device from a microcontroller like Node MCU, which we have seen right now, to a full-fledged server that runs on an MQTT library and connects to an MQTT broker over a network. MQTT libraries are available for a huge variety of programming languages. For example, for Arduino it is there, Android it is there, C, C++, C#, iOS, Java, JavaScript, and so on. MQTT broker is heart of any publish subscribe protocol, and it can handle thousands of concurrently connected MQTT clients. It's responsible for receiving all the messages, filtering the messages, and determining who is subscribed to each message, and then sending the message to the subscribed clients. It also holds the session of persisted clients. Okay, so I will talk about it, so it will be clear very soon, including the subscriptions and miss messages. Okay, and it also authenticates and authorizes all the clients. Let us see how the connection is established in MQTT. So the connection is always between one client and the broker. The clients never connect to each other directly. To initiate a connection, the client sends a connect message through the broker. The broker responds with a connect acknowledgement message, that is CONACK, and a status code. And once the connection is established, the broker keeps it open until the client sends a disconnect message or the connection breaks because of some reason. Okay. Now this packet of this connect message looks like this. It has all these fields like client ID, client session, username and password, last will topic, and this keep alive. So let us see these fields one by one. Client ID is actually unique and identifies each MQTT client that connects. Yeah, please, ma'am.
PPT is not visible.
Not visible. Oh, just a minute. Okay, is it now, ma'am? Is it visible now?
Just a minute. Just a minute. Yes, sir, it is visible.
Okay, thank you, ma'am. Okay, so look at this packet structure again. It has fields like client ID, clean session, then optionals like username, password, and last will message, and keep alive. Okay, so we'll see all these fields one by one now. Client ID is unique actually for each and every client, and it identifies each MQTT client that connects to an MQTT broker. Clean session is actually useful when there is a client which is already connected earlier and now maybe it got disconnected due to some reason, now wants to connect again. So now when it wants to connect again, does it want to have the old settings as it is or something? So for that persistent session, that term is used. So it tells the broker whether the client wants to establish a persistent session or not. Clean session, if it is false, then the broker stalls all the subscriptions for the client and all the missed messages for the client that subscribe with a quality service of level of 1 or 2. And there are 3 quality of service levels. In case of quality of service level 0, these messages are not stored, and this doesn't happen. Okay, and if this clean session is true, then the broker doesn't store anything for the client and remove all the information from the previous any previous persistent session whenever the client connects again. Okay, username and password, they are optional, so MQTT user they can send username and password for the client authentication authorization. Whenever you want that only particular users should be able to join, then this particular mechanism can be used. A will message is something like what we do in real life. Many people, they write the will that if something happens to me, do this, something like this. Okay, my property, this goes to this or that or something. So here will message is having a similar kind of thing. Whenever a client disconnects ungracefully, means suddenly, without giving a disconnect message to the broker, then there is a will message. If it is defined, then this broker will send the message to all the subscribers, the will message of this particular client. Okay, to just to notify them that this person or this particular client has disconnected ungracefully. Okay, and keep alive is actually the time interval in seconds that the client specifies and communicates to the broker when the connection is established, and we'll talk about in detail also later on, but right now and in response to this connect message, the broker will send a connect acknowledgement. Okay, that is connect message. In this message, you can see that there are only 2 fields. One is the session present, and the second one is connect acknowledge flag. Actually, it is written here as written code because that connect acknowledge flag is written in actually a written code. So it's written here as written code. So if the session present flag is true, it indicates presence of a session from the previous connection. And if it is clear session, as we have discussed in the previous slide, then it will always be false. Okay, and this written code, it tells the client whether the connection attempt was successful or not. Okay, so 0 indicates successful connection, and as per the old MQTT, have a look at the written codes. As you can see here, it is 0 for the successful connection, And if the connection is refused, then there could be a number of possible reasons like unacceptable protocol, identity issues, server is unavailable, there is problem with the username or password, or the particular client is not authorized to connect. Okay, so based on that, a particular return code will be part of that connect message actually. Now, once the connection is done, the next step is either publishing or subscribing, okay, and unsubscribing. Okay, so to publish, the client must specify the topic, what kind of quality of service, then the return flag. Return flag is, we will come to that later, but this returning the message till it gets delivered, and what kind of payload is there as a part of the message, and the payload itself. Okay, so these are the fields for the publish. And when the client sends a message to a broker for publication, what the broker will do, it will read the message, it will acknowledge the message according to the quality of service level, and it will process the message. Okay, processing by the broker includes determining that which clients have subscribed to the topic and sending the message to them. For the subscription, the client must identify and specify the topic and quality of service. And after the subscription request, the broker sends a sub-acknowledge message, that is acknowledgement to this to the client. Here you can see the structure of publish packet, this message. It includes a packet ID. It's actually a unique number, and that is assigned to each packet, and there is a topic name. Okay, it's a simple string that is maybe hierarchically structured with forward slashes as delimiters. Here you can see, for example, sweet home / drawing room / temperature. Okay, so what actually happening is that this particular client is publishing the temperature of the drawing room of this particular sweet home. Okay, and there could be maybe the humidity level, or maybe some other protocol from the drawing room, or maybe the temperature of bedroom 1, bedroom 2. So maybe this topic name will change based on that. Then you can see the quality of service. The quality of service, as I mentioned earlier, there are 3 levels, 0, 1, and 2. And this quality of service level, it will determine what kind of guarantee a message has for reaching the intended recipient. The recipient could be a broker or client. Okay, broker obviously, because everything will go to the broker. Okay, and return flag, it defines whether the message is saved by the broker as the last known good value of a specified topic. Okay, sometimes the client is publishing something and suddenly it gets disconnected. So whatever was the last message from that client when it was connected, if this return flag is set, the broker will store that value. Okay, and whenever any new client subscribes to that with that, at least it will come to know that based on the quality of service. Okay, payload is the actual content of the message, and as I mentioned earlier, MQTT is data agnostic, and it's possible to send images, text in any encoding, encrypted data, and virtually every data in binary. Packet identifier we already discussed. Okay, and there is a duplicate flag actually. So in certain mechanism, when there is a quality of service other than this 0, there will be exchange of that message again. Okay, the message will be published again. So if that message is getting published again, then this flag would be set to indicate that this is a duplicate message actually. So let us see the quality of service level and what happens for a different level. The level 0 is QoS 0, which is known as at most once. So it is minimal quality of service level, and there is no guarantee of delivery. Actually, it's like fire and forget. Okay, the client sends it and forgets about it. Okay, so this doesn't have any guarantee, and here the guarantee is same as the underlying TCP protocol, whether this particular message will be delivered or not. Then there is quality of service level 1. Yeah, here it is at least once actually. So it guarantees that a message delivered at least one time to the receiver. What does it mean? There is a possibility that message may be delivered more than once. Okay, here sender stores the message until it gets a pub acknowledge packet from the receiver that acknowledge the receipt of the message, as you can see in the figure. And if the sender doesn't receive this pub packet in a reasonable amount of time, the sender will resend the published packet with that duplicate flag on. Okay, so here there is a possibility that the same package message may be sent multiple times or may be delivered multiple times. And one more, the highest level is exactly once. Here it is like the highest level of service in MQTT. It guarantees that each message is received only once by the intended recipient, and it is the safest and the slowest quality of service level. And the guarantee is provided by at least 2 request response flow, as you can see with reference to publish. The broker is sending pub received, and then pub relay, and then in response to that pub complete packet is coming. So if we compare this micro participant to mute, okay, please mute yourself.
Prapti madam, please mute all the participants. Because I could
am I audible, sir, now?
Yes, sir, clearly audible.
Yes, sir, you are
Okay,
audible.
so if we try to find an analogy of this with our real world situation, for example, you are at home and you want your son to do some work. Okay, for example, close the window. Okay, it's raining heavily outside and you feel that the outside rain may come into your house. So you want to close. So you just say, Jayesh, close the window. Okay, and you are saying, and then you are not taking any follow-up. That is like, and Jayesh might not have heard that message, and maybe we don't know whether that window will be closed or not. Okay, so that is like quality of service level 0, where Jayesh is not responding to that. So, but you are okay with that. The second one is that you ask Jayesh, please close the window, and Jayesh responds, okay, Papa, I'll do that. Okay, so that gets acknowledged. But here also there is something like that. Even though Jayesh has said yes, but Jayesh might be watching a movie in his mobile and he just say, oh yes, but he forgets to close the window. So that may also happen. So that is quality of service level 1 actually. And quality of service level 2 is something like that. You ask Jayesh, please close the window. Jayesh says, yes, Papa, do. And you say, okay, make sure I'll not ask you again. Again, he said, no, I have done it. Then it's like quality of service level 2, which is the highest, does guarantee definitely, but it is slow. Okay, so if you look at the public, this publish acknowledged message, it is sent only in case of quality of service level 1 and 2, and it only includes the packet ID, and that packet ID is same as the published packet. Okay, whatever ID was there, the same one. So based on that, all this the client will come to know that whether it is acknowledged or not. Okay, by comparing the packet ID. Subscribe message, you can see here the structure. It has a packet ID is always there, and you can see the fields now in that subscribe message. There could be multiple subscription also. And for each subscription, there has to be a quality of service and topic. Okay, these two things are must. okay, for each subscription. And based on that, the client sends a subscription acknowledge message, that is sub-ACK, and that message is also having the same packet ID, and there are certain written codes, okay, for each subscription. So this written code would be identifying that whether it is successful or not, and if it is successful, then what is the quality of service which is there. For example, if it is 0, then the subscription is successful with quality of service level 0. If it is 1, then the subscription is successful with quality of service level 1. And if it is 2, then the connection is successful with QS2. And if it returns 1 to 8, then the subscription has failed. Okay. Similarly, as you can publish, you can subscribe, you can also unsubscribe, and then in that case, this is the message format, that it has packet ID and the topic which you want to unsubscribe. Okay, and there is no QS specification required here. When the broker receives this unsubscribe message from a client, or sorry, that's published subscriber, it will regardless of whatever it was the quality of service level defined when at the time of subscription, the broker will unsubscribe that particular client from that particular topic. Okay, and there is this acknowledgement also message which is sent by the broker to the particular client, that is subscriber in this case, and there is only packet ID there. Okay. And once the client receives this packet, this particular message, it is confirmed that now I'm unsubscribed from a particular topic. So let us see what topics are actually, and how can we subscribe to multiple things and other things. So topics are actually the UTF-8 strings that the broker uses to filter messages for each connected client. The topic consists of one or more topic levels, and each topic level is separated by / as we have seen earlier. The topics are case sensitives, they are very lightweight, and the client doesn't need to create the desired topic before they publish or subscribe to it. The broker accepts each valid topic without any prior initialization, and each topic must contain at least one character, and that the topic string permits empty strings. Okay. Additionally, there is / is also a valid topic, but it creates some, we will see that if we only do it or what happens. There is a concept of wildcard actually. Just like in the game of playing cards, there are jokers. Here we have wildcard cards. When a client subscribes to a topic, it can subscribe to the exact topic of a published message, or it can use wildcard cards to subscribe to multiple topics simultaneously. Okay, a wildcard can only be used to subscribe to the topic, not to publish a message. Okay, and there are 2 levels of wildcard. One is single level, and here you can see one example. My home / ground floor / plus / temperature. So here a single level wildcard is used. This particular client is subscribing to all the topics which starts with my home / ground floor as the first and second level. In the third level, there can be anything. Okay, but the fourth level has to be temperature. Okay, so here you can see 2 valid example. In the first one, my home ground floor side, it is as it is, like the first 2 levels. Then this plus sign is here, you can see this can be anything. It can be living room, it can be kitchen, it can be terrace. Okay, it can be the basement, but the last one is again temperature. Okay, so here this single level wildcard, so this particular topic it's valid example, this first one. But if you look at the third one, my home ground floor, so the first two levels are matched, but third one is kitchen or kitchen whatever. But what about the last one? It is not as same as temperature. Okay, here in this case, and here in this case, the ground floor has been replaced by first floor. Okay, so if any client has subscribed to something like this, and there are 4 clients which are publishing message with these topics, this particular client will be getting these first 2 messages. Okay, because this particular wildcard means they have subscribed to this, it matches. Now there is one more level of wildcard called multi-level wildcard, and in that case the hash sign is used, and ultimately it is responsibility of broker to determine that which topic match. So generally this multi-level wildcard, this hash will be the last character in that topic. So here one, if for example a particular client is subscribing with my home ground /ground floor /hash, please ignore the space if it is there. Okay, so here when the client has subscribed with this, then you can see here there are 4 clients which are publishing message my home ground floor. So these first two fields or first 2 levels, they match directly, and then this hash sign. So whether there is 1 level or 2 level or 3 level or more after that, whatever is there, this particular client will be getting those messages. Okay, so these are there. But if you look at the last one, the client which is having a topic something like this, the second level is not matching. Okay, only first level is matching. So this particular client will not be getting messages published by this particular client having the topic name this. Okay, for that particular topic it will not be receiving any message. It will be receiving messages only for this first 3. And there are topics beginning with this $sign also. They have a different purpose, and actually they are reserved for the internal statistics of MQTT broker. So as a user, we cannot use it. And some of the examples would be like $sys broker clients / then connected, disconnected, send, uptime, and all those things. Okay, so we cannot use it then, and we cannot publish message to this. So some of the practices which one has to do while deciding the topics. Never use a leading / means your topic name should not start with this, as it may create a lot of issues. Never use space. Blank space in a programming is always a nuisance. Okay, so avoid it. It may create there are many characters, white spaces and others, they have different meanings, so it's better to avoid them. Keep the topic as short and concise as possible. If possible, use only ASCII characters and avoid non-printable characters. Embedded unique identifier or the client ID into the topic. I'll be showing you an example of using this MQTT. So at that time, I'll show you that it will help, because there would be hundreds of people. For example, we are doing an experiment and we are reading temperature. And if we say the name of the topic as just temperature, there would be, and this data is going to a broker, and that broker may be connected with so many publishers which are publishing with that same name. So it will create issues. Okay, and never subscribe to hash, because then everything will come to you. Don't forget the extensibility, because many a time we keep on adding more and more topics or sensors in that case, because we are reading them. So that we have to keep in mind whenever we are doing that. And for example, for we are converting a home into a smart home, and we just start with a temperature, okay, and we are publishing that temperature now. So if we take the topic name as just as temperature and we start, then it may be a 3 BHK house, okay, where you want now interested in, now you are, instead of just one room, you are now putting this temperature sensor in each and every room. Okay, so bedroom, drawing room, bedroom 2, master bedroom, maybe kitchen or whatever. Okay, so you have to decide the topics accordingly. So if you start with something like my home or my sweet home, then this and then temperature, it will be a better thing, and use specific topics, not the general one like this temperature or something. Okay, no doubt it has to be meaningful to you so that it becomes easy. I told you about persistency session earlier. As I mentioned here, if the connections gets interrupted somehow, then every time reconnecting will take a lot of burden for that. So client can request a persistent session when it connects to the broker again. When that clear session that is not set, it's false, this persistent session will save all the information that is relevant for the client on the broker, and this client ID then the client provides when it establishes the connection to the broker. The broker identifies the session. So when this persistent session is there, what does it store? It stores all the subscription of a particular client, all the messages in quality service level 1 or 2, or that the client has not confirmed yet, they are there. All new quality of service level 1 or 2 messages that the client missed while the client was offline, that is also stored there. All the quality of service level 2 message received from the client that are not yet completely acknowledged, they are also stored. And as I mentioned earlier, clean session flag, if it is true, that means non-persistent session. And if it is false, it means a persistent session. Return flag, as I mentioned earlier, a written message is a normal MQTT message with the written flag set to true. And in this case, the broker stores the last written message plus the quality of service for that topic if that flag is set to true. Okay, and each client that subscribes to a topic pattern that matches the topic of the written message receives the written message immediately after the subscribe. And the broker stores only one written message per topic. Okay. Last will and testament, as I mentioned earlier, it's similar to writing a will or something. So when a client wants to disconnect, generally it is expected that client sends a disconnect message and it needs to get acknowledged. But sometimes due to maybe XYZ reason, if the client disconnects disgracefully, okay, then this last will message comes into picture. It provides a way for client to respond to these connections, and it helps implement various strategies when the connection of a client drops, or at least inform the other clients about the offline status, because some maybe they are not directly connected. So somebody has published to it, now it is waiting again and again. Why that message is not coming? I've already subscribed to this or something. Okay. So, and then there is a keep alive time. Actually, it's a time interval that is permitted to elapse between the point at which the client finishes transmitting one control packet and the point it starts sending the next. It is the responsibility of client to ensure that the interval between the control packet being sent doesn't exceed the keep alive value. And in absence of sending any other control packet, the client must send ping request packet. Okay. When the broker receives ping request packet, the broker must reply with ping response packet to show that the client that it is still available. And this particular both ping request as well as ping response, they do not contain any payload. If the broker doesn't receive ping request or any other packet from a client, the broker will close the connection and send the last will message if specified. Okay, the maximum keep alive time as mentioned in this is protocol is 18 hour 12 minute 15 second. If the keep alive time interval is 0, then this mechanism is deactivated. And there is a client takeover mechanism also, where generally it happens that a client who is disconnected somehow will try to reconnect again. And this is something like a half open connection, because at client broker side it is there. So if the broker detects a half open connection, something like this, it will perform the client takeover. Now in this case, what is happening is that the broker will close the previous connections for the same client, because each client is having a unique ID, and establishes a new connection with the client. And this behavior ensures that the half open connection doesn't stop the disconnected client from re-establishing the connection. Some of the changes, MQTT 5 is already there now. And some of these are that there is a new session and message expiry features. Feature is that which allows to set a time limit for each message in session. And if a message is not delivered within a predefined time period, the message is deleted. Also, the concept of negative acknowledgement has been introduced, and based on the predefined restrictions, the broker can send an acknowledgement to reject particular messages. Restriction can be based on a maximum message size, or maybe the maximum quality of service, or unsupported feature, etc. There is a concept of shared subscription also, which is now fully implemented. It allows multiple MQTT client instances to share the same subscription on the broker, and it makes it possible to load balance the MQTT client that are deployed on the cloud cluster. It is something like that if there is a shared subscription between two clients who have subscribed to the same topic, then whenever the broker gets a message with that topic, it will send it to not both the subscriber in that particular shared subscription, only to one, and when the next comes, it sends it to the next one. Okay, so that way it does. And there is topic aliases also, which allows you to substitute the topic strings with an integer, and to make the message processing easier for the receiver, the polar format indicator, whether it is binary or text, okay, including the MIME style content type, have been added in this version 5. Okay, so I request some of the participants to install the MQTT client from the App Store. Yeah, so in the desktop, generally we use this MQTT box, and in the mobile, you can download the MQTT client, and we will try to send some messages with a topic name and see how does it get received. Okay. If at least 2 or 3 can do it. Meanwhile, I'll also check whether that code is now running again, so that I can. Show you the ThingSpeak if it's working.
Hello. Hello,
Yes,
sir. Am I audible?
Yeah.
Sir, actually participants are posting in that chat box. Can you please check it? Participants are asking to repeat what is to be done actually.
Yeah, okay, I'll do it, please. Okay, I want the participant to download MQTT client. Okay, that app you need to download from mobile. Okay, in App Store, mobile App Store, whether you are using iPhone or Android mobile, there are various MQTT client applications. you need to download MQTT client. On a desktop, you can have MQTT box.
Participants can ask the questions either in the chat box, or you can just unmute your mic and you can ask the question if any.
Okay, somebody has mentioned Anupama ma'am, I think she's on desktop. So you have to search for MQTT box. Okay. And meanwhile, I was we found that somehow that ThinkSpeak library got deleted somehow. So reinstall that library, and now we'll be able to show you that using that ThinkSpeak, you can see right now, I think the serial monitor data, it's reading that data, and I'll take you now to this ThinkSpeak, where you can see that now the new readings. Okay, it has changed now. The humidity has increased. This value is 48.3 at 1536. Okay, and now the temperature reading in between, it was not connected, so no data is there. So here you can see that the real-time data is now getting transferred to ThinkSpeak. Okay, and let us now go to that MQTT. Okay, so MQTT, those who have installed MQTT client on their mobile, you need to connect to the this particular broker.mqtt-dashboard.com. Okay, I'll try to write it somewhere, so okay, it becomes easy for you. Okay, so in that you have to do that, and in port you have to give 1833. It is 1883 port which you have to give. Okay. In my mobile, I have app called MQTT tool. If you can see it here, yeah, MQTT tool. So in that, in the host, it is sometimes it is written as host. So host, you have to write broker.mqtt-dashboard.com, and in the port you have to enter 1883. Client ID, it will generate automatically, so you need not to worry about it. Username and password, it is also optional. Okay, and you can keep the session clean if you are connecting, because there is no point if you are connecting first time. And then you can see a button like connect. So once you connect it, if it is successful, you will get that message. Okay. Okay, then here in the screen, I'll demonstrate that. So I have created a client as a publisher here, and now I'm adding a subscriber to that. Now here in that client, you can see I have given name. I'm interested to know the temperature, or I'm publishing the temperature actually, but it is I've given some unique name. So NBK_temp, and quality of service, I've kept it at least once. Return flag, so that package will be stored, at least the last one will be stored. And as far as the payload type is concerned, we can give it as a string, JSON, XML characters or something, or as a binary array or octal array or decimal or hexa array, and the payload. Okay, so here you can see that payload I'm entering, for example, temperature equal to 33.11 degree Celsius. So I'm not, and I'm subscribing now to this particular topic here, NBK temp, and I'm putting quality of service right now. Okay, so here you can see, okay, this was at least once, so that whatever was stored is going there. Now I'm changing this value again, 35.22. I am publishing it. So the subscriber is getting those with the field IDs and all those things which we had discussed. Okay, so you can using this MQTT box in your laptop or desktop also itself, you can experiment this, that how it works. And if we change the parameter, what will happen? For example, I am putting here hex array. Okay, if it is of hex array type, and then if I try to publish, what will happen? Here you can see that I mentioned that payload type as hex array, but what I tried to give a string with different things, so it gave me message invalid payload, and the payload data should match the payload type. And now let me enter 41. Okay, let us see what happens when we send 41H. Okay, and once we publish, here you can see capital A coming, the ASCII equivalent. Okay, so 41H, it represents capital A. So actually it is this. So that is why in one of the tip it was said that you use ASCII characters whenever you are doing it. Okay, if it is like this, I don't use the special characters, another thing. Okay, so with that, let me come to the references. This entire presentation majority part, this MQTT part, it is based on a very good tutorial on the HiveMQ. So everything was majority based on that. And you can visit the Oasis website also, where you can find this specification. And there is one more, stevesinternetguide.com, another very good tutorial for MQTT. So thank you all. Thank you for the patient listening.
Thank you very much, Kalani sir.
My pleasure, sir.
So the session, I'm sure that this session will be very much useful to the participants, particularly for the hands-on session. Sir, I request you to send your presentation so that we can upload it on the team, as well as we have prepared the Google Classroom. So
Okay.
we will upload your presentation there.
Yeah, I've already, I think, mailed the presentation.
Okay, then I will just download it and will send it to you.
Please.
I think you have sent it to me, right?
Yeah, I'll send it.
Okay, I will check it. Okay, thanks.
Okay. Thank you, sir. Thank you.
Okay, thank you very much, sir.
Yeah. Any question?
Audience, if you have any questions, you can unmute your mic and directly ask to sir. You can discuss with sir.
My email ID is nbkalani@rediffmail.com. Please feel free to write to me. I'm writing this in this message, because that ID I use regularly.